The
Yes,
topic is gravitational potential. When we talk about the gravitational potential, actually this gravitational potential is a work done due to gravity, right? An amount of work done due to gravity. That is an amount of work
more
done.
done
So,
to
which object does this work, and where is that work done? So, amount of work done. This is what the amount. I mean, the concept of potential. But when we will have a definition of the potential according to the exam, that is the amount of work done per unit mass, work done per unit mass. It is very important,
Hmm.
not per kg, per unit mass, to bring it from infinity. Actually, it is also a point dependent quantity, a position dependent quantity. So you can say that gravitational potential at any point is the amount of burden to bring, or per unit mass to bring it from infinity that point to that point in gravitational field. Okay, so this is basically represented by phi. This is its symbol, and as from definition, it is work done per unit mass, so its unit is joule per kg. So I will write this stuff back. Okay, so its defining equation is basically that gravitational potential is work done per unit mass. Okay, this is its defining equation, which gives you, or which leads you towards its unit joule per kg. And for the equation which is mean exactly related with gravitational potential, this is potential, right? So when I talk about the gravitational potential, that is basically the burden due to gravitational force. So it would have a different formula. Gravitational potential. ठीक है जी? तो
Yeah.
gravitational potential के लिए आप क्या करोगे? That will be represented by this, and it is basically work done due to gravity. तो आप इसको यूं कर लीजिए कि that phi is equals to work done due to gravity divided by mass, and that work is what is that work? Work is basically F into D. ठीक है जी? Work is equals to F into D. So I'm just writing F into D divided by this mass. It would be carried on, and then according to the gravitational field strength, if I say that this is F, then it would be your negative G, mass of the planet, mass of the object, divided by r square, right, into this. D is coming from the formula, and this m is coming from the formula. So when you will cut this m with this m, you will left with this d, and you can write that this d can be written as r in the gravitational, or in all the gravity topics. So now my gravitational potential is basically summarized at minus g
The
m
capital M.
divided by r. ये एक इससे कटा, right, and
So
you
sir,
are
G is
getting
sir,
one.
D is this.
Actually, d is that distance for which I'm going to bring this body to the near the earth. I can take it as a length, or you can consider it as a radius. This separation कह सकते हो आप. So this is the point from where you are going to, uh, at which you are going to bring this body. So let's say this is your point A. So the work is done. It is WA, and this is an infinite point, right? It is infinity. अब आपके पास जो planet है ना, let's say this is the planet, and you are going to bring it. This is the distance r, small r. ये जो आपने d उसको move करवाया है ना, this is the distance which has been traveled by the body when it was brought from this point infinity to this. So actually this is your infinity.
D plus
ठीक
R.
है? Infinity, and this remaining is your r. This is basically
Okay.
r. और अगर मैं इस remaining को लिखूं, this one, so can I write that
Infinity
infinity
minus R.
minus r,
Yeah.
right? So
Yeah.
it is actually, logically we can write it infinity, but because the scientists have a they have a agreement on that, or they are convinced on that, their infinity will not give you any calculation. So that's why we just consider it कि यार ये r ही distance है which has been traveled by this body. Now go back to this point. So this is your gravitational potentials formula. You have derived it for 2 to 3 months. Its derivation is also there. So you have to recall this and you have to derive it. So these are the aspects of its exam aspects. Now, very important thing which is being asked to you, that is, why do you carry a negative sign over there? The work is done due to this work is done due to negative, due to attractive force. So attractive forces are considered as negative forces. That is why. Second thing, what you have to consider over there, I will give you some clues about that, and those clues are actually very important. That at infinity, if you are going to put some effort to bring the body to the gravitational field, what is the work at infinity? Infinity, you are doing nothing now to bring it to the infinity, to the gravitational field. It is like just out of the gravitational impact. तो आपको कोई force तो नहीं ना लगानी पड़ी, वहां पे कोई work नहीं करना पड़ा. So remember one thing, that work done is zero at infinity, so that the potential is zero at infinity. You are doing nothing to bring it. It is simple. मैं आपको ऐसे समझा देता हूँ कि if we are having some pets, so if they are not pets, the time when till they are not pets, do you need to work on those? जब आप उनको pets नहीं बनाना चाहते, they are free birds. So
Yes.
do you need to work on them? Do you need to
No.
spend some energy on them? Do you need to spend some time on them to make them
No,
pets?
sir. No, no, no.
You don't want them to be pets, you just make them free. So when a body is
Yeah.
at infinity, I don't want to bring it in the gravitational field, so I have no need to do some work.
Okay.
इसकी दूसरी एग्जांपल ये है कि if I don't want to maintain my mass or maintain my body weight, so do I need some workout?
No.
नो. इन्फिनिटी जिधर जा रहा है जाने दो, इश्यू ही नहीं है भाई, देखेंगे. लेकिन व्हेन आई वांट अ लिमिटेशन कि नहीं यार मुझे यहां तक इसको लाना है, सो डू आई नीड सम वर्कआउट?
No, sir. You
करना
don't need
पड़ेगा
it.
ना, मुझे वर्कआउट करना पड़ेगा. सो व्हेन आई bring my weight or mass from any unlimited value to a limited value, I used to do some workout. ऐसे
Okay.
in that workout or during that workout, what happens to my body? Do I lose some energy? Or not? So same happens to the body which is brought in the gravitational field. So when you are going to bring when you are going to bring a body in the gravitational field, actually you are working on it, you are doing some work on it, and that body loses its energy continuously, and it comes closer and closer and closer. So as a body loses some energy, that numerically it takes negative sign. So you will write all those concepts here one by one. You can write any of these two or three, but I will give you all these three. आप कुछ भी लिख सकते हो. Work is done due to attractive forces, so it is negative. At yes,
At
along with
at
that,
infinity, work done is
as
equal to zero.
yes, as the object is coming closer, as the object uh, comes closer to the surface, it loses energy. As the object comes closer to surface. Third, at infinity, these are what I'm going to write now, that is numerical explanations. At infinity, work done is zero.
Yeah.
At infinity, gravitational potential is zero, and as object moves closer to the surface, it decreases. At object is brought closer to the surface, as the object increases. और मजे की बात आपको बताऊं, zero below the zero values goes to negative. The values lower than zero or less than zero, value smaller than zero is negative. You can write any 2 3 points according to the this given scenario. Now we will talk about the graph. Graphical representation पे आते हैं. I mean graph mean whenever I will talk about the graph, I mean I'm talking about the variation, right? So variation is actually, first of all, as I told you, that this is the planet, right? So on the surface of the planet, it would be having a certain value, and then beyond that, it would be changing. So मैं distance को ना इधर move, I mean I'm going to make this axis here. Why I'm going to make this axis here? Because here the gravitation will be 0. It will be, let's say, minus 10. Suppose it is minus 20, and so on. So this is the distance r, right? As the distance is increased, it it is 0 here na, infinity पे कर लेते हैं कि it is 0. So it will touch the axis, but because it is not, my graph is not showing infinity, it is r, 2r, 3r, 4r, and 5r, and 6r. So will it touch axis? No, it will not touch axis. Why? Because मेरा ग्राफ इंफिनिटी पे तो नहीं है ना. आपका एक्चुअली जो ग्राफ बनेगा, it will be something like this. It will not touch the axis,
Yes,
right?
sir.
So the
Yes.
property of the graph is that potential is inversely proportional to r, but with negative sign. Here it is very important, with negative sign, but it never touches the axis. It never. And gravitational potential is smallest where? At surface. So these are some points you have to remember, and we can use this graph for our calculations of gravitational potential energy. So I'm just going to switch this topic over there. Gravitational potential energy. So gravitational potential energy is basically a point where I can say that it is actually energy. When I talk about energy, it is only work done. It is not a work done per unit mass. So just the perception is it is only work done for any amount of mass or at any amount of mass. I can simply define it that gravitational potential energy at any point in gravitational field is the work done at a test mass, the mass you are going to test. No need to indicate point unit mass. On a test mass, to bring it to that point from infinity, to bring it to that point from infinity. Gravitational potential energy is basically represented by either GPE or usually we represented by U. कोई फर्क नहीं पड़ता इससे. You can write both of them, and that is equals to G negative G M divided by R. And because you are going to work on a small mass, so you will write small m with this. So आपने जो formula याद रखना है, that equation is that gravitational potential energy is G negative G capital M small m divided by R. ठीक है, R square नहीं है, it is R. So if I just go to the relation between gravitational potential and gravitational potential energy. If you say that phi is equals to minus g m divided by r, आपके पास जो u है वो सिर्फ क्या है, minus g m divided by r whole multiplied by m. So again I say that gravitational potential energy or gravitational potential GPE, GPE लिख देते हैं, मैं मुझे लग रहा है ज्यादा हम GPE यूज करते हैं, is equals to m times phi. This is very
So, sir,
important
phi is
equation
equal
for you.
to
How
gh.
phi is equals to gm divided by r. Now the next formula is GPE is equals to your m. So if I write if I write this negative g m divided by r, Okay, so I can make this to be transformed with G. आपको ग्रेविटेशन फील्ड स्ट्रेंथ के बारे में पता है ना? It
Yes,
is
sir.
minus G m divided by r square.
Yes.
So if I just give this 1 r to gr, so that will be equals to minus g m divided by r. So now I'm gonna replace this, that g p e is equals to m into G into R. So that again here is an assumption that R can be taken as height above the surface, because now we are moving above the earth. So your GPE is basically also equals to
Yeah.
mgh, right?
This is
So these are some relations which are being asked to you from GPE topic. But the most important thing जिसके लिए मैंने ये टॉपिक अभी शुरू किया है, that is the relation of phi and पोटेंशियल, सॉरी phi and gp. एक्चुअली जब आपका ग्राफ आता है ना, मोस्टली आपका जो ग्राफ है, मोस्टली जी सॉरी जो पोटेंशियल का ग्राफ है, पोटेंशियल इज लीडिंग टू योर जीपीई, आपके पास ग्रेविटेशन पोटेंशियल एनर्जी पे लेके आता है. सो लेट्स से ग्रेविटेशन पोटेंशियल एनर्जी एट एनी पॉइंट इज द वैल्यू ऑफ phi एट दैट पॉइंट इनटू मास. तो आप कैलकुलेट कर सकते हो. So जब आप कैलकुलेट करते हो, तो लेट्स से यू हैव अ ग्राफ
so I
लाइक
can
दिस इज बेसिकली द ग्राफ ऑफ योर ग्रेविटेशनल पोटेंशियल. ठीक है, ये आपका ग्रेविटेशन पोटेंशियल का टॉपिक है. जब आपका ये ग्राफ ग्रेविटेशन पोटेंशियल का है, so can I say that I can calculate gravitational potential energy at any point? Let's say this is your value of gravitational potential minus, में values कर लेते हैं, -10, -20, -30, -40, -50, and this all is actually having 10 power 8, 9, 10 joules per kg, क्योंकि जो planets होते हैं, बिग स्टार्स और प्लैनेट, उनके लिए ग्रेविटेशन पोटेंशियल की वैल्यू काफी ज्यादा होती है. सो फॉर एग्जांपल दिस इज बेसिकली द आर. ठीक है, this will also be given to you in numbers. Let's say it is 1.1, let's say it is 1.2, suppose it is 1.3, it is 1.4, it is 1.5, and that distance is given to you in terms of 10 power 12 kilometers, right? So if a rock is there and that rock is traveling from the surface of planet to away from it, ये एक rock था.
okay.
ठीक है, and
जी.
that is moving away. तो how will we find कि यार इसकी जो ग्रेविटेशनल पोटेंशियल एनर्जी है एट एनी पॉइंट और एट द डिस्टेंस कितनी है? सो आई विल फिगर आउट दैट पोटेंशियल ओवर देयर. फॉर एग्जांपल मुझे अगर ग्राफ दे दिया जाएगा ना, तो आई विल बी क्वाइट कन्वीनियंट. मुझे सबसे ज्यादा जो आई मीन आसानी से मैं कैलकुलेशंस कर सकता हूँ, दैट इज फ्रॉम ग्राफ. सो फॉर एग्जांपल आई वांट टू फाइंड आउट द ग्रेविटेशन पोटेंशियल एट अ डिस्टेंस ऑफ 1.3 into 10 raised power 12 किलोमीटर. तो मुझे क्या करना है कि मुझे यहाँ सबसे पहले अपने ग्राफ पे जाना है कि व्हाट इज पोटेंशियल हियर, right? So
Okay, yeah.
potential is almost -9 into 10 की पावर 8 joules per kg. ये आपका यहाँ पे पोटेंशियल है. और mass of the rock मैं आपको दे देता हूँ. Let's say mass of the rock is 180 kg. ठीक है, तो आप यहाँ पे इस पॉइंट पे इसकी ग्रेविटेशनल पोटेंशियल एनर्जी कैलकुलेट कर लोगे, एंड दैट ग्रेविटेशनल पोटेंशियल एनर्जी इज 180 times 9 times 10 power 8. So you will get some number, calculator पड़ा हुआ है. This is what that we are going to find gravitational potential. अब आपसे एक और क्वेश्चन आता है, you have to find change in gravitational potential energy. So that can also be done from the same point, same uh, graph. For example, the gravitational potential at point A, let me mark it point A and let me mark it point B. So here the gravitational potential is -40 and here gravitational potential is -9, -10 कर देते हैं वहां पे. So you will say that gravitational potential energy का change, मैं change की बात कर रहा हूँ, potential at B minus potential at A. So that was 180 kg rock, and potential at B was -10, and potential at A was minus 40. So minus minus plus 40 into 10 raised power 8. So that will give you, yes, what number will you get? 5.4 times 10 power 11. If your answer is positive, it means your gravitational potential energy increases. If your answer is negative, this is for positive value. And if the value is negative, this shows that your gravitational potential energy decreases, right? एक ये हो गया.
Yes.
फिर आपको फॉर्मूले से चेंज इन ग्रेविटेशनल पोटेंशियल एनर्जी एक और तरीके से कैलकुलेट करनी है. The change in GPE is also equals to GPE at point B minus GPE at point A. So ये important चीज है जो आप कैलकुलेट करोगे, बिकॉज इसके लिए आपको काफी सोचना पड़ता है, और ये ग्राफ से नहीं होगी. ये वाली जो ये जब ये आप इक्वेशन लगाओगे ना फॉर
Yes, sir.
फॉर्मूला इक्वेशन, ठीक है, नॉट फॉर ग्राफ, ठीक है, ये वैल्यूज आपको गिवन होंगी एम की, आर की, वगैरह वगैरह वगैरह. सो फॉर दिस पर्पज आई विल जस्ट सिंपली पुट दैट दिस इज जी एम एम डिवाइडेड बाय आर एट बी विद नेगेटिव साइन. माइनस का साइन ये हो गया, मैं दोनों साइंस अलग अलग लिख रहा हूँ. देन नेगेटिव, ये आपका फार्मूले का है, फार्मूले का साइन है. देन नेगेटिव जी एम एम divided by R at A. Is it G M M as common, and you will write 1 upon RB with negative sign plus 1 upon RA with positive sign. ये वाला formula भी आपका बहुत दफा use हुआ है, and you have to use this for calculations. So change in, ये change in GPE का है. So change in GPE is G M small m into 1 upon RA minus 1 upon RB. So this is the minor difference. वैसे normally हम लोग क्या करते हैं, we just put the value of B minus A करते हैं ना, लेकिन when you will take reciprocal, it would be there. आप चाहो तो एक formulation और कर सकते हो, but I will not recommend you कि आप calculations में फंस जाओगे. RB into RA डिवाइडेड बाय, यानी R1 R2, इसको RB की बजाय इसको मैं क्या कर देता हूँ, R1 R2 डिवाइडेड बाय R1 माइनस R2 माइनस R1, ठीक है, डिवाइडेड बाय R1 into R2. So this is that which can be used to use the change in gravitational potential energy.